Can everyone see my Jupyter notebook?
Mm-hmm.
All right. So I'm going to be going over this SQL section on Pandas, section 5. And let me pull that up just so everyone knows exactly what we're going over. This is, if it loads. Running a little bit slow today. And module 1 and section 5. It is the very last lab, using SQL with Pandas Lab. So that is what I'm going to be going over today. Before we jump into it, does anyone have experience with SQL? No?
I did SQL-like.
You did SQL-like?
Not
okay.
light, but it was like it. I supported.
Okay.
I supported Pick Basic with Unix, so we're doing a lot of those commands, which were the same, format: select, join, get, kind of stuff.
Okay, very cool. That will definitely come in handy for this section. So does anyone, before I go into this, does anyone know why we use SQL, or besides Shelly Ann, since you're the SQL expert? So the reason you'll use SQL is that up until this point, all of our data has been either in a CSV form or an Excel form. And there's pros and cons to that. So the pro is it's really easy to load in the pandas. The con is that if we had a CSV on customers' usernames and passwords, and me and Shelly Ann and Lashani were all sharing it, anyone could go in there, any of the three of us could go in there and completely change people's usernames, passwords. It's not very safe to do that. And so that's why we'll use databases, is that you can store a ton of data in a database, and not everyone has access to change it. At my last job as a data scientist at a railroad, I didn't have write access to our databases. They just let me have read access, and that was probably a smart reason. And with a database, as opposed to a CSV, I can do queries, and this is very powerful. So our databases were larger. If I tried to grab our entire database and put it onto my hard drive, my hard drive couldn't handle that. So you do queries where I only want this amount of data, or I only want the first 100 rows, or I only want where in the last 90 days, or I only want where it's this locomotive number, or I only want where it's in this city. So you can do filters on that. With a CSV or an Excel file, you have to load in the entire file. You can't filter it, what you load in. So I'm going to demonstrate what PandaSQL does here. And this is just some code to load in this Titanic database. This is just a website where it's being hosted. So don't worry too much about this. Endpoint is this data frame.head. So I have this data frame, and it is some Titanic data. So what PandaSQL does is, let me show the documentation because it's kind of funny. So PandaSQL allows you to perform queries on Pandas data frames. And what this allows people to do is that people who are more familiar with SQL than they are Pandas, you can run these SQL queries that you're really familiar with on Pandas data frames. So yeah. So if anyone has a background in R, if anyone has a background in SQL, or if later on in life when you're a data scientist and there's some new person that wants to learn Pandas and they have a background in SQL, you could point into this library and they will thank you. So that is what we're going to do. And so first, I want to do a filter on this data frame. So let's say, my screen up, I only wanted I wanted to do a filter on this data frame where females are over the age of 40. So right now, I have everything in this data frame. I have male, female, I have all ages. Let's say I only wanted females that are over the age of 40. All right. So traditionally with pandas, this is how I would do it. I would do df, and then I'd set this my two filters. So the first filter I want to do is on the sex column. I want to set this where it only equals to female. So sex equals female. And the second filter I want to do is on this age column where age is greater than 40. And if we do this, so I end up with this data frame, that's this filtered data frame. So these people are females and their age is greater than 40. Does this make sense so far? Good deal. So now we're going to do this with PandaSQL. And this is where I can write that SQL query. And so when you do this, use this PandaSQL, you will always be using this line right here, and I will show you why. But to start, we're going to use it. Data frame. There we go. So I will import SQL df from PandaSQL. And this time, I'm going to write a SQL query. And a SQL query, if you've never used a SQL query before, is going to look a little bit strange to start. So we start with a SQL query, you start with a select statement. And this is, you're selecting which columns you want from the data frame or database. In our case, we want all columns. So in SQL, there's a shortcut for that, and that is star. That's saying I want every column from this database or data frame. Next line is from, and this is what the database is or data frame is. In this case, it's a data frame. It is from the df data frame. And now we can do our filters. So our first filter is on the sex column again. So where sex equals female or female. And where so the second filter is where age is greater than 40. So that is my query. And I have this instance right here, PySQL df, and I will put that into my PySQL df, and I get the same results. So you get the exact same results, and we should. So this is using pandas. This is how you would traditionally do it. This is doing it with a SQL, using PandaSQL, using a SQL query. So if you have a strong background in SQL, or if you just like doing it, if this way makes more sense to you going forward, feel free to use this. But yeah, does anyone have any questions or comments? This is kind of the main part of this entire lesson, entire lecture, entire study group, is that you can do filters with pandas, or you can write a SQL query and do the filter on the data frame.
Now that statement that you have up there with the PySQL df, that is what?
Right here?
Yeah, that's what feeds into the SQL statement, right?
Say that one more. That is what feeds into the SQL statement?
Or picks up the SQL statement.
Mm-hmm. Yeah. This is what is running the SQL statement on this data frame.
Okay.
All right. And so in most of the documentation that you see in this PySQL df, it's going to have you run this lambda statement. And all what this is doing is it's making it easier going forward, so you don't have to type as much. If you don't want to do that Lambda statement, you could do the exact same thing you could import, so you just do this, and then do SQL df q, and then globals. And you get the same thing, it's just according to the people that wrote this, it's a little bit easier and a little bit more Pythonic to do it this way. I keep going to the wrong one. I'm going to switch them. So it's more Pythonic to do it this way versus this way every time. So it's good to know. So let's do another query. This time, I only want to grab the name column when the fare is greater than 15 and survived is true. So if I'm going to do this in Pandas again first, anybody know how to do this in Pandas? It's all right if you don't. So we'll start with the data frame, and then we'll build our filters into that. So the first filter is on the fare column. I want fare to be greater than 15. And the second one, I want survived to be true, which is a 1 in this column. So survived equals 1. And if I run this, I get every column. I only want the name column. So to specify to grab only one column, I could do this, and I want name. So I end up with the name column. And something that when I was kind of learning Pandas that I kind of struggled with is when you have multiple conditions. So I have where fare is greater than 15 and where survived equals to 1. You have to put parentheses around everything or it'll throw an error. And it took me a while to figure that out. So if I remove these parentheses, yeah, so it doesn't like that. It doesn't know where one statement ends and the next one begins. So you have to put parentheses around your statements. So if you get this, and I don't think this, I think a lot of Pandas errors are really good about telling you what's going on. I do not think this is one that's very good. So put parentheses around it, and we will run it, and we get everyone there. All the names of people that survived and paid a fare greater than $15. So now we are going to do this in PandaSQL. So again, I need to make a query statement. And a couple things with SQL is, one, I could write this all in one line. I prefer to write it in multiple lines. Every time I write any SQL method, I will go to a new line just because I think it's a little bit easier to read. And also the statement, the SQL methods are not case sensitive, so I could do select. Again, I think doing all SQL methods in all caps, I've kind of seen that a lot in industry, and I think it's a little bit easier to read.
Agreed.
Awesome. Good deal. Yeah, I'm not a SQL expert. I mean, I remember when at my last job, I'd look at some people's SQL queries and just, I don't know how they read it, how they wrote it. And so you're looking at an experienced person do SQL, it's pretty crazy to see.
Yeah, I'm not that experienced because I was in a former language that fed into this. So I understand the whole concept, but seeing all those joins kind of just threw my head over and over again, trying to figure where the data was joining to. So I get it.
Yeah. When there's multiple, when there's like more than two tables, it's really, for me, it's really hard to follow when there's multiple joins like that. So the first part of the SQL statement again is I want to select which columns, and this time I want to grab just the name column. So I want to grab name. I want to grab it from the data frame df. The first condition is when the fare is greater than 15. So the fare column where fare is greater than 15. And the second condition is where survived equals 1. All right. And put it in. And I get the same results. It does put it in a Pandas data frame for you, so it's a little bit cleaner. This is a Pandas series. But so is it the same? So this is 139, this is 012. But this is Mrs. John Bradley Cummings, and then Mrs. Futrell. Yeah, I think it is the same.
Jeff, how did you get your Jupyter notebook to autofill like that? Like, how does it autofill? Because mine doesn't autofill when I'm typing in.
It doesn't autofill at all?
No. Is it just?
Yeah, usually after you import it in, after you import a package in, if you have any instances of the classes, they should autofill. So if you do like import pandas as PD, so like a common one, pandas. So if I do PD dot data frame, so I tried that, and if that does that work? I don't know if you have a Jupyter notebook open.
No, I don't, but it doesn't work like that for me. So is there something you can something that you can upload that allows that would save a lot of time.
Yeah. Let me write this down. I'd have to do some searching, but let me get back to you on that. I don't remember if I had to change anything or not. Yeah, but I completely agree with you. Autofill is really nice. I take definitely.
Yeah, you don't have to cut and paste as much.
Yeah, I have to rely on it a lot. So let's go to another one. So now let's look at, I'm going to pull up my data frame again so I can see it. So let's say we wanted the survival rate of men and women. And survival rate, because survived is a binary column, if I take the mean of that column, survived dot mean, it will get me the survival rate in this data set. So in this data set, 35% of people survived total. But we want to break it down by gender, by men and women. So there's a couple different ways to do this. And I'm going to start with pandas. So first, I am going to do a filter on, where'd it go? The gender column. Where gender equals male. And then I'm going to grab the survived column. And if I take the mean of that, so in this data set, 14% of men survived. And then if I do the same thing, but with female, I'll see 71% of females in this data set survive. So it was good to be a girl if you're going to be on the Titanic.
Yeah, they all said women and children go first.
Yeah. I think in the movie they shot someone over that, if I remember correctly. But good deal. So that is one way to do it. I'm going to propose a better way using the group by function, the group by method. Mm-hmm. And I'm going to group by this sex column. And then I can grab the survived column. Survived. And then if I take the mean of that, I should get the same thing. Yeah, female 71, males 14. I think this code is, I really like using this group by. I think it saves a lot of time, and it's something it's probably one of the pandas methods that I use the most is group by. So that is how I would do that in straight pandas. And one other thing I just wanted to touch on real quick is referencing columns. So there's two ways to reference, let's say this, the age column. So I can reference it like that. And I can also reference it like this with the dot notation. These are equivalent. I always use the square brackets, and that's just out of habit. There is an advantage to using square brackets, is you can't use dot notation if there's a space in any of these columns. So if it was passenger space ID, it would throw an error. But passenger, so let me just make a real, I don't want to go too off subject. So I'm going to make a new data frame real quick. So I'm going to call this first column column 1 with a space. And it's going to be a 1, 2, 3. And I made a mistake. So I have a single column 1, 2, 3. If I wanted to reference column 1, I could do it with a square bracket notation. Well, it's df1, not df. Can I get it? But if I do the dot notation, it'll throw an error. Yeah. So just something to think about. I've got a couple of questions about that, so I just wanted to share it real quick. Does that make sense?
Mm-hmm.
Good deal. I'm going to delete all this. And so I got the survival rate of men and women on the Titanic in using pandas. Now I'm going to do it using a PandaSQL. So make my Q statement. And yeah, here it is. So they have these functions in SQL to take the average, I could take the count, and I could take the sum of different columns in the data frame. And I'm going to use this average right here. And I want to take the average of the survived column. And I want to take it from the DF data frame, and then I want to do the group by. And I want to group by yeah, the sex column. Cool. And I get the same result. So 71 for class 0 and 1 for class 1. So it's going to alphabetize it. So it's the females are 0 and the males are 1 in this instance. All right. So now I have a little surprise, surprise for everyone. I have a little bit of a quiz. So hope everyone was paying attention. It's going to be an anonymous quiz, so if everyone's on a computer, go to kahoot.it and type, it'll ask for a game pin, and the game pin is 558989. And it'll ask you to put in a nickname. I'm going to ask that you don't put your actual real name in there, because I'd like to keep this anonymous. Just use it as a check for you. All right, one player. All right, 5 people. Let's get started. So I have this function where I do a filter, so df, and I do a filter on this data frame where it's greater than 14. Which of these pandas, which of these statements is equivalent to doing a filter where age is greater than 14 on the data frame df? And you want to pick the color or the symbol on your screen. All right, so the correct answer is this one right here. So I'm selecting all columns from the data frame df where age is greater than 14. So this is doing a filter on the data frame df where the age is 14. It's not specifying any columns or anything, so it's grabbing all the columns. All right, question number 2. And we are not keeping score. So a little bit of a longer filter on the data frame. So we're doing it, filter on the age is greater than 50 and where gender equals female. All right, so this is grabbing all columns from the data frame df where fair is greater than 50 and gender equals female. So this one, I'm selecting where gender is greater than 50. That doesn't really make sense compared where we're doing a filter where gender equals female. And this one, we're doing just grabbing the age column. In this instance, we didn't specify any columns. All right. I made the answers kind of similar, so they're kind of hard to like differentiate. So sorry about that. All right, still tied at 0. So this is going backwards. I'm giving you the SQL query. Now we're going to do the filter in Pandas. So select age from data frame where gender equals female. All right, so yep, this is the correct answer. This would be doing a filter on the data frame df where gender equals female, and then this line right here, this is only grabbing the age column. This right here would be grabbing all columns. So if this was a select star from df where gender equals female, this one would be doing a filter on the data frame where gender equals female and only grabbing the gender column. And this would be doing a filter on the age column where age equals female. And I'm going to warn, I did make a mistake on here. There should be, all these should be double equal signs since this is pandas, but just as info. All right. There's just two more. So now the group by function. So we're grouping by the embarked and then taking the mean of the fare. How would we do that in SQL? All right. So, yep, grabbing the fare column, taking the average of it from the data frame DF, and then we're grouping by the embarked column. And one more. So select the average fare from the data frame DF, group by P class. How would we do this in Python, in Pandas? All right. Yep. So it is, we're going to group by this, the P class column, and then we're going to take the mean of the fare column. So that is it for the quiz. All right. It's just alphabetical. No one got any points. We're all winners. Let's go to the lab now. So this is the Using SQL with Pandas Lab. I'm going to start going through this a little bit. Does anyone have any questions before I jump into the lab? No? All right. So in this lab, we'll learn the various ways to query a data set and get information using pandas. So we'll be able to query data frames with SQL using the Pandas SQL library, query data frames by slicing with conditional logic, and use the query method to access data. So this was using the Pandas SQL. I went over this. Slicing with conditional logic, this is what I went over as well. And the query method is, we will find out. I did not go over this, so it'll be a nice surprise. So the first thing, we're going to import pandas, numpy, matplotlib, and a %matplotlib inline. So import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, and %matplotlib inline. And if you're ever going to do any sort of PyTest on any of your work, anything that starts with this %, this is a Jupyter magic command, and this is going to throw an error in your PyTest. So if you end up using this, just do it to do that, and that'll be fine. So next, read in the data from Titanic CSV and store it as a data frame in DF. Display the head to ensure that everything is loaded correctly. I always do the ls just to see what's in the current folder that I'm in. So this is the file that I want to import in the pandas. So I'm going to do read CSV, Titanic.csv, and I want to display the first 5 rows. So looks good, looks familiar. Yeah, everything looks good. I guess we can take a look at the data types, see if anything looks weird. So the first three are integers. That's what I would expect. P class is a text file, is an object. It looks like it should be numbers. So as I'm going through this, this should be something I'm aware of, that even though these are numbers, they're actually a text. Name and gender are both text files, objects. Age is a floating point. Siblings and I think this is parents aboard are both integers. Ticket is a text file, which it looks like it should be with the letters. Fare is a floating point. Cabin is a text file as well, and embarked is. So everything's the way it should be except for P class. I need to be careful when I'm working with this one. So one of the most common ways to query data with pandas is to simply slice the data frame so that the object returns contains only the data you're interested in. In the cells below, slice the data frame so that it only contains passengers with second or third class tickets, denoted by the P class column. All right, so let's do it. So I'm going to do my format on the P class column. And I want to check if it is 2 or 3, or second or third class. And remember, this P class is an object. So let's say I treated it as an integer or as a float and didn't put quotes around this. This is going to give me an issue. P class equals 3. It returns nothing because there's no number 2s or number 3s in this. They're text files. They're a text column, I should say. So if I put quotes around it, should get some results, and I do. And everyone is second or third class. And I'm kind of paranoid. I always do like a bunch of crazy sanity checks, make sure I'm doing things wrong. So in this case, I'm going to do value counts. Normalize equals true. So in this data set that I did the filter on, 73% are in third class, 26 are in second class. So did my filter right. There's no first class, there's nothing else. All right, moving along. We can also chain conditional statements together by wrapping them in print.
Sorry, can I just back up and ask a question on that? Because you also said it was an object. Does that mean that there could be other ones that it's just not picking up, or are there nulls in there or something?
So if we look at, that's a great question. If we do a value counts on the unfiltered data frame, I believe there's question marks in it. Yeah, so that's okay. What made it an object. And
there is first class, right? Like there seems to be.
Mm-hmm. So this value counts is just on this filtered data frame that's on second and third class.
Okay.
But yeah, that's a great question. This question mark is if I was going to build some sort of algorithm that was predicting whether someone survived the Titanic or not based off gender, age, how much they paid for their ticket, what class they were, I would probably want to do something with these question marks. All right. We can also, so in the cells below, slice the data frame that so that it only contains passengers with a fare value between 50 and 100 inclusive. So I will grab my data frame and I'm going to do a filter on the fare column where it's greater than, where it's between 50 and 100. So that's greater than or equal to 50. And do I need an and or an or in here? Do I want it greater than 50 and less than or equal to 100, or greater than 50 or less than or equal to 100?
I think that might be an and.
Mm-hmm. Yeah. And I want to take a look at the describe method just on the fair column. So our minimum value is 50 and our maximum value is 93. And then let's look at if we did an OR. So our maximum value is now 512 because it hit this first condition, and it only has to meet one of these conditions with an OR statement, and 512 is greater than 50. And since it's an OR, it doesn't care about this next one because it already got its true. So nicely done. Move back my and statement. And yeah, nice. So they kind of talk about the square brackets versus the dot notation. Use dot notation syntax and slice a data frame that contains male passengers that survive that also belong to P class 2 or 3. So I'm going to grab my data frame again. So the first thing I'm going to filter is on the sex column and just filter out my male passengers. So male. And P class is equal to 2. And we're P class. And I forgot my quotes because P class is an object. And so I was thinking I was going to run into an error here, and I did. Can anyone see anything that looks wrong in this data frame? So I want males and that belong to second class or third class.
You're going to put extra brackets around that DF or thing because it's just picking one versus it's just picking male and 2 versus.
Exactly. Yeah, I need to put parentheses around these two because I want it to be an and then an or inside of here. So it has to be male, and then it has to be either second or third class. So right now I have some females in here, and I just want males that belong to second or third. And if I do that, now I just have, and we can do a sanity check again. This time I'm going to do the sex column. And then another way to check is dot unique. So there's only males in this. And then I'll do the same thing with P class. So it's just second or third class. So that is all good. All right. Any questions? Making sense so far? Cool deal. So practical example, slicing data frames. So we have a sneaky suspicion that women and children survived more than men, and that rich passengers were more likely to survive than poor passengers. The easiest way to confirm this is to slice the data frame into data frames that contain each subgroup, and then quickly visualize the survival rate of each subgroup with histograms. So that's exactly what we're going to do in the cells below. In the cell below, create a data frame that contains passengers that are females, as well as children, males included, under the age of 15, exclusive. So there's going to be 2 filters on this. So the first one is passengers that are female. So it is the sex column. And you want to do a filter where the sex is female, or do a filter on the age column. I forgot my parentheses. We're less than 15. And then I also want to do one on the male column. I'm going to call it male DF. And this is just a single filter where sex equals male. So now In the cells below, create histogram visualizations of the survived column for both data frames. Bonus points if you use plot.title to label them correctly. All right, so to do that, and I'm going to do a subplot so I can plot them both next to each other. To do a subplot, I'll need to make two axes instances. And what this is saying is I want to make a subplot. I want one row, two columns, and axis one is going to be my graph one in it. Graph one is, I believe it's left to right. So this will be my left graph. And we'll quickly find out. So yeah, so that's my left graph. If I made this axis 2, nope, nothing changed. 1, 2, 2. I think if I make a second axis, yeah, there it is. So this is axis 1, this is axis 2. And then, so I need to grab my women and children data frame. I'm gonna plot this on this axis 1. And I wanna do, what do I wanna do? I wanna create a histogram of the survived column. Okay, so I wanna grab the survived column, and then I wanna do a histogram, and I wanna set the axes equal to axis 1. So now there is women and children. So remember 0 is they did not survive, and a 1 is they did survive. So more women and children survived than they did not survive. I'm gonna put a title on this. And women and children. All right. And then I'm gonna grab my male df, the survived column, dot hist, and axes equal 2. So this is my male column, my male histogram. Let me put a title on it. Title, males. Yeah, males. So it looks like we kind of found this out earlier that more males did not survive than they did survive. And make this a little bit bigger. I'm gonna do 20 by 5. It's too big. Let's do 15 by 5. All right, and then I always do this because I think it kind of looks cool. And plot.style.use. This is optional. I think it makes the plots a little bit more appealing to the eye. Oh, it did not like that. Oh, it's just ggplot. So just with a couple of lines, you can kind of make it look a little cooler. I think it's kind of cool. It looks hand drawn, which I like. And it's what this package. And then this package is what makes the background and kind of makes it look cool too. So any questions so far? All good. Good deal. So yeah, they kind of summarizing it. Women and children survived at a higher rate than males. And then it looks like we're going to do the same thing with first class and second class and third class. So I want to do a filter on the P class where it equals to 1. And I want to do a filter where it's equal to second. Now I want to do an OR. DFP class is equal to 3. All right. And I'm going to kind of copy some of the code that I have up here. I'm going to make it a 15 by 5 inch figure. I'm going to make subplots again. And this time I'm going to use first class df. And we're looking at the survived .hist axis equals axes 1. And plot.title, first class. So cool. And then I'll make my second axes, which is second and third class. 1, 2, 2. So that looks good so far. And what was the name of the data frame? Second and third class. Plot, oh, .hist. Second and third class. All right. I think that's where I'm going to stop for the night. So we're running out of time. Does anyone have any questions? No? Well, hopefully when you get to this section, it'll be a little snap, and hopefully the SQL section goes well for you. If anyone has any questions, definitely feel free to reach out. I wrote down, I'm going to try and follow up with you, Anne, about the autofill not working. If anyone has any other questions or anything, definitely feel free to reach out. Otherwise, have a great night.
Thanks, Jeff.
Thanks, Jeff.
Yeah, no problem.
Thanks, Jeff.
No problem. See ya.